Good morning, student. Today we have discussing Thevenin theorems and Norton theorem. Thevenin and Norton are a reciprocal. Thevenin theorem. According to Thevenin theorem, states that any two-terminal output terminal of a active linear network containing independent source can be replaced by a simple voltage source of a magnitude Vts. This is called the Thevenin voltage in series with a single resistance Rth, and Rth is called a Thevenin resistance. Rth is the equivalent resistance of the network when looking from the output terminal with all source removed by replace their internal resistance, and the magnitude of Vth is equal to the open circuit voltage across the output terminal. Steps following for solving a Thevenin theorem. First, we have removed the load resistance. Again, we have find the Thevenin voltage across open terminal. Third, we have remove the all energy source and find the equivalent resistance of a circuit. Next, we have identify the Thevenin equivalent circuit. Next, we have connect the load resistance in Thevenin equivalent circuit and apply the Ohm's law KVL. We have identified the value of load current. For example, find the RTH and VTH across terminal A and B. Step first, we have removed 5 kilo ohm resistance shown in a figure. Second step, we find out the Thevenin voltage. We have seen the voltage, the one loop is shown in a figure. 8 ohm is a open terminal, so there is a no current. So current in a 4 ohm resistance equals to 3. Current value is 3 milliampere. Then the VTH is 12 volt. Remove all energy source are removed. Current source take as a open circuit. Voltage source take as a short circuit with their internal resistance. Next, calculate the RTS where 12 kilo ohm and 4 kilo ohm resistance are in a parallel with series 8 kilo ohm. Then solving the RTH equal to 11 kilo ohm. Next step, we have identify the Thevenin equivalent resistance and connecting the load resistance. Then the value of load current and load voltage. Norton theorem. Norton theorem states that any two terminal A and B of a network comprised of a linear resistance and independent source voltage of a source may be replaced by equivalent current source and the parallel resistance. The magnitude of a current source is the current measured in a short circuit placed across the terminal of pair A and B, and the parallel resistance is the equivalent resistance looking into the terminal pair A and B with all independent source has been replaced by their internal resistance. The basic procedure follow for the solving Norton theorems. First, remove the load resistance. Find the RS by shorting the all voltage and open circuit of all current source. Find IS by placing the short circuit link across the output terminal A and B. Find the Norton equivalent circuit and find the current flowing through the load resistance. This is the example finding the current in 40 ohm resistance using Norton theorem. First, we have short circuit against terminal A and B and the solving equation. Apply, find the current applying Ohm's law. I1 equals to I2 equals to is 1 ampere. Then the I short circuit equals to 2 ampere. Remove the taking an open circuit and remove all energy source. Then R parallel resistance equivalent resistance RT equals to R1 into R2 upon R2 plus R3, that is a 6.67. Having we have Norton equivalent circuit connecting IS and RS. Now connecting load resistance in a circuit, then we get the value of current. Thank you, student.